Hey guys, so we're gonna do lesson 2 right now. A lot of this beginning stuff might be review, so you can probably go through it really quickly, but I'm going through it each step at a time just in case, okay? So right now we're gonna focus on right triangle trig. And with right triangle trig, we have 6 trig functions to use. Now, as you can see, I have a right triangle here. I know it's right because of the 90-degree angle. But with right triangle trig, excuse me, we have to identify what angle we're talking about. So this is just a general triangle that I'm gonna use theta down here. So theta is this angle. Now, of course, I could always use theta in this angle right here, but that changes a couple of my sides. The hypotenuse will always be across from the right angle. Opposite side will always be across from theta. So of course, if theta was up here, the opposite side would be here. And then of course, right next to is what adjacent is. Again, if theta was up here, adjacent, these two would switch, okay? Now, it's good that when we're doing trig and everything, we want to label our sides so we know we can put the ratios in the right spot. So let's talk about those ratios. Sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, when it comes to our other 3 trig, we're going to talk about 2 ways because we need to talk about it as a reciprocal as the other 3 trig functions. So that way we can plug it in our calculator when we're able to use our calculator. And we'll also talk about it in a ratio standpoint of the opposite, adjacent, and hypotenuse. Because if you look at your calculator right now, you will see that there's only 3 trig functions on there: sine, cosine, and tangent. So how are we supposed to get cosecant, secant, and cotangent? Well, the way to put it in on your calculator is cosecant is the reciprocal of sine. So 1 over sine theta, which really means when it comes to our sides, it is hypotenuse. Hypotenuse over opposite. Thought it was about to make a mistake, but I didn't. Secant is 1 over cosine, which is hypotenuse over adjacent. And then cotangent is 1 over tangent, giving us adjacent over opposite. So like I said, the first thing we want to do when we are finding these ratios is we need to label our sides according to the degree. So our angle degree is going to be alpha. So we're looking at this angle right here. So 5 is across from the 90 degrees, so it's the hypotenuse. 4 is across from the angle, so that's opposite. 3 is right next to, so it's adjacent. And now I can write down my 6 functions. Sine alpha equals opposite, which is 4, over hypotenuse, which is 5. Cosine alpha is adjacent, which is 3, over hypotenuse, which is 5. Tangent of alpha is opposite, which is 4, over adjacent, which is 3. The good thing about doing these 3 first is since we know that the other 3 are the reciprocals, now all I have to do is flip them. Cosecant of alpha equals 5 over 4. Secant of alpha is 5 over 3. And cotangent of alpha is 3 over 4. All right, example 2 has us verifying the following triangle. So we want to see that this triangle is similar to the triangle above. Similar means that the sides are proportional and that the angles are the same. All right, so we have 2 angles here. We have to figure out which one might be the same as alpha. So if I look I'm going to probably try to find beta first. So if I look at beta, that means this would be my adjacent, opposite, and hypotenuse. So let's look to see if those sides are proportional. So I'm going to write down that I'm looking at the sides. So it doesn't matter which triangle you put first, as long as you're always putting that triangle first. So I'm going to do this bottom triangle here. So let's see, the adjacent side is 9. And in example 1, the adjacent side would be 3. Does that equal the opposite side of this one is 12? The opposite side of example 1 is 4. And does that equal the hypotenuse over example 1's hypotenuse? And what do you know? 9 over 3 is 3. 12 over 4 is 3. And 15 over 5 is 3. So yes, they are proportional. This means that alpha and beta equal. We can also compare the ratios of your trig. So example, we did all of our trig stuff up here, right? Well, let's do that. Let's do sine of beta equals, and that's opposite over hypotenuse. Well, if we simplify this, we get 4/5. And what do you know? Our alpha was also 4/5. So the idea about having similar triangles is that the ratios are going to be equal. They're going to simplify to equal fractions. Okay. Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. C is the most important, right? Because C is the hypotenuse. Okay. And the other thing I want to point out, if you haven't learned this already, is in geometry, sides are lowercase angles are uppercase. And that's how you can always identify what you're trying to solve for or what you have based on the alphabet. Okay. All right. Here we're going to go through our special right triangles because we are going to be doing some trig without the calculator. So we have this 30, 60, 90. What I want you to imagine is that if I put a 30, 60, 90 on top of a 30, 60, 90, what happens here? Well, this was 60, right? According to a picture. This is 60 because I'm flipping it right over. This becomes 180, correct? And then here was 30, and this was 30, so it's almost like 60, 60, 60. Hey, that's an equilateral triangle. An equilateral triangle says that they have all the same angles and all the same sides. So let's do that. Equilateral triangle says that all the sides would be equals. Let's label them all as X. All right, now I'm going to compare this and go back here. So that means the hypotenuse right here is X. Now what happens here? What happened to that side? All I did was double that side. So technically, if this were X, that means this side right here would be half of X, or X over 2. Now, when it comes to this side right here, I don't know, but what can we use to find it? Considering we have two sides, we can find the third by using Pythagorean theorem. So let's do that now. So I'm going to label this L, just so I can look at my algebra and I don't have too many variables in it. So I would have L squared plus our X over 2 squared equals X squared. Now remember, I'm solving for L right now. So I'm going to square this and move it over. I'm going to do 2 steps at once, guys. So I get L squared equals X squared minus X squared over 4. Again, I just squared that. how do we add fractions? We need common denominators. So when we do common denominators and we subtract, we get L squared equals 3x squared all over 4. Now, to get rid of a square, we square root both sides. So L equals, well, the square root of 3 is square root of 3. The square root of x squared is x. And the square root of 4 is 2. And there we go. Now, if you want, we can actually do our functions. So sine of 30 equals, well, 30 is, or sine is opposite over hypotenuse. So I would have x over 2 over x. Well, guys, if we reduce that, that just becomes 1/2. So sine of 30 will always reduce to 1/2. Cosine of 30. Well, cosine of 30 is adjacent, which this is our adjacent right now, over x. So we get square root of 3x over 2 all over x, which leaves us with square root of 3 over 2. Tangent of 30. Tangent of 30. So that would be opposite over adjacent. So I get x over 2 all over the square root of 3x over 2. All right, let's reduce that. Well, the x cancels, the 2's cancel, and I'm left with 1 over the square root of 3. Now, right now, I'm not going to worry about rationalizing the denominator because I'm going to find the other 3. But in the future, we really want to pay attention to whether directions tell us to rationalize it or not. So this means that I can do my cosecant of 30 just by flipping it. So it equals 2. Secant of 30, flip it, would be 2 square root 3. And cotangent of 30 equals square root of 3. All right, so we of course can do this for 60 degrees also, but I'll let you do that on your own. But now let's talk about our 45. 45, 45, 90. So when the angles are the same, their corresponding sides, which is their opposite sides, should also be the same. So if I say this side is x, well, this side is x. Because the opposite angles, corresponding sides, same angles, same sides. Now to find the third side, I can do the Pythagorean theorem. So x squared plus x squared equals, let's label this h squared. So right here I get 2x squared equals h squared. Take the square root of both sides. The square root of 2 is the square root of 2. The square root of x squared is x. And there we go. We have our h, our hypotenuse. Now let's do our trig functions again. So I get sine 45, which would give me x over the square root of 2x. The x's cancel, so 1 over the square root of 2. Cosine 45, adjacent is x over the hypotenuse. Again, 1 over the square root of 2. And then we have tangent 45, which is opposite over adjacent, x over x equals 1. All right, let's do the other 3. So cosecant of 45 would be square root of 2. cosine, secant, there we go. 45 is also square root of 2. And cotangent, well, the reciprocal of 1 is 1. Awesome. All right, so what we're going to do is we're going to organize all of these findings into a chart. We're also going to rationalize the denominator this time. So what I mean by that is that you do not have a square root in the denominator, okay? So if we were to put these all together, well, sine of 30 was what? It was 1/2. Cosine of 30 was square root of 3 over 2. Tangent, remember, was 1 over the square root of 3, but we're going to rationalize this. So I'm going to rationalize it here, which means I multiply both top and bottom by the square root of 3 to get rid of that square root on the bottom. We get the square root of 3 over 3. And now we're going to flip them. So we get 2 here. 2 square root of 3. Again, let's rationalize it. So square root of 3, multiply top and bottom. And then cotangent, we just get square root of 3. Let's do our 45s. We had 1 over the square root of 2, which we're going to rationalize now, which is the square root of 2 over 2. I'm still going to write this, even though you know it's the same, because it helps us find our secant better. Okay, tangent 45 is 1. So cosecant is square root of 2. Secant is square root of 2. Cotangent is 1. All right. 60. If you did this on your own, you would find that your cosine and your sine switch, and your tangent flips as like a reciprocal, because now instead of it being opposite and adjacent, those sides are switched. So does the numerator and denominator. So 60, sine of 60 is the square root of 3 over 2. Sine or cosine's 1/2. Tangent is square root of 3. And then I have to flip them off for the other ones here. So I get 2 square root of 3, which we know when rationalized is 2 square root of 3 over 3. Let's see, secant is 2. Cotangent would be 1 over square root of 3, but we know rationalized is square root of 3 over 3. All right, these guys, you want to memorize these. Okay, start doing it now. All right, and what we're going to do is we are going to use these charts up above to be able to solve this problem. So we can actually solve for an unknown of a special right triangle, the 30, 60, 90, or the 45, 45, 90, without a calculator. Now I'm going to show you how to do that now. So right here in example 3, it says find the missing measures. Well, missing measures are missing angles and missing sides. So I'm missing 2 sides and I'm missing an angle. Which one's the easiest to find first? The angle, right? Because the angle, we would have 180 minus 90 minus 30. And that would give us our leftover angle of 60. So what I'm going to do now to label, because we were missing 2 sides, and I want to make sure that I'm showing my work and not confusing the two. So I'm going to label the hypotenuse C, and I'll label this side A. Now, here's a special thing that I wanted to show you. There are lots of times that we can make little mistakes, right? And of course, if we make a mistake and then use that number in our next part of the problem, we were already wrong. So when you're finding different parts of one, I don't want to say shape, but one problem, try only using the numbers that are given to you, not the ones that you're discovering, okay? So I'm going to do cosine because this is adjacent, opposite, hypotenuse. So let's find C first. So I have cosine of 30 equals adjacent, which is 7, over hypotenuse, which is c. Okay, so I don't like the c in the denominator, so let's bring that over. I have c times cosine 30 equals 7. We're solving for c, so c equals 7 over cosine 30. Now this is great, just leaving it as here, but if they actually want you to break it down all the way, we can still do that, because we can go back to our chart and say, hey, cosine of 30, well, 1 over cosine is secant 30. And we can go to our chart now and say, wait, secant of 30 is 2 square root of 3 over 3, which means if we put this together, our hypotenuse is 14 square root of 3 over 3. Very good. Now, what I was saying before, try not to use information you just discovered, because if you made a mistake, it gets a little tricky, right? Because I just discovered C. And if we had two sides, we can always find the third side by using the Pythagorean theorem. But I'm taking that chance if I was wrong to begin with. So I'm actually going to stick with just the 7 and the 30 here. So now if I'm looking at A is opposite, 7 is adjacent, so that means I'm using tan. So tangent 30 equals opposite, which is A, over 7. So this gives me 7 times tangent of 30 equals A. Well, tangent of 30 is the square root of 3 over 3. And if you look now, guys, there's nothing else we can do with it. So we're done. Yay. Let's try another one, because not always are the diagrams going to be given to us. So we need to practice drawing it out. Do you always have to have your triangle this way? No, you can have it the other way and label certain sides the way you want to. Just be careful. So I'm going to switch this up a little bit, just so we get used to doing things a different way. So I'm going to switch my triangle up. The angle that's given me is 60. Now I know we keep putting the angle of 60 down here, but I'm going to change it up just so you can get used to it. I'm going to put 60 up here. And the hypotenuse is 20. Well, the hypotenuse is always across from the right angle. Now we're finding the unknown sine lengths and missing angles. So of course, right away we can see that 180 minus 90 minus 60 is 30. There's our missing angle. Now let's go for our sides. Again, you could label this A, this B, no matter what you want. I'm going to say A and B. And this time I'll solve for A first. So I would have opposite and hypotenuse. Opposite and hypotenuse is sine. So sine is 60 equals A over 20. Now remember up here, I rearranged it first and then I plugged in. Well, if you want, guys, you can plug it in right now. Sine of 60 is square root of 3 over 2. So I'm just showing you different ways that you can do this. Now, how do we get A by itself? I multiply both sides by 20. Now, if you wanted, many of you could probably see that, hey, wait a second, 20 divided by 2 is 10. So we actually can make this 10 square root of 3. All right, we found our A. Again, we can use the Pythagorean theorem to find B, but just in case we made a mistake, it would be better for us just to use the 60 degrees and the 20. So B is adjacent hypotenuse, so that's cosine. So we get cosine of 60 equals B over 20. I'll do it the other way this time. I'm just going to do the 20 over first. It's just showing you multiple ways that you can figure this out. And then cosine of 60 is 1/2. Well, 20 times 1/2 is 10. Awesome. All right, let's do some applied problems. Right triangle trigonometry has many practical applications. For example, the ability to compute the lengths of sides of a triangle makes it possible to find the height of a tall object without climbing to the top or having to extend a tape measure along its height. The following example uses trigonometric functions as well as the concept of an angle inclination. Now, a lot of us use angle of elevation throughout the years, but inclination is inclining, it's going elevating up. So what we need to remember for elevation is that our initial side is going to be at that baseline. So it's horizontal at the base, and then we're looking up. So let's do some of these now. These problems, of course, you want to draw them out first. So if you want, guys, for an extra note, remember when I said when it's elevation, we have a baseline and we're looking up. So elevation is this lower angle. Okay, the angle of inclination from a point on the ground 30 feet away from the base of a water tower. So we have a water tower, and of course I am not a good artist. So here's my water tower. I am 30 feet away, and we're looking at the top of the water tower. Now it says the angle is 60 degrees. Now the water tower, hopefully we had some good engineers, right? Because this should be at a 90-degree angle. We're finding the height of the water. Now, the last two problems, we were finding all the missing parts. We don't have to in this case. We only have to answer the question. Okay, so keep that in mind. So now if you look at this, if we're trying to find h, which is the opposite, and we are given 30, which is the adjacent, what trig function are we using? We are using tangent. So tangent of 60 equals h over 30. All right, so that's 30 tangent 60. Again, we do not need our calculator technically, but if it wants it to the nearest foot, we are going to have our calculator so that way we can round it in the right direction. For those of you who are coming right from 1050, some of you made the mistake in the past that you would have the correct answer, but you didn't read the question all the way because it wanted you to round it. Okay. So if we actually put this in our calculator right now, we would get it that the height is approximately 51.96. But since we are going to the nearest foot, that 9 tells us to round up. So we are at 52 feet. All right, this one is going to be amazing for me to draw because it never comes out right. So bear with me. In order to determine the height of a California redwood tree, two sightings from the ground, one 200 feet directly behind the other are made. Okay, so here's my tree. I'm just going to draw a line for the tree, guys. Okay, so we have one observer that's making a measurement here, and another one is making it here. And this is 200 feet away from each observation. I actually drew it better without making the tree this time. Okay. If the angles of inclination were 45 and 30 respectively, how tall is the tree? Okay, first of all, this was my tree, so I'm going to put this as h. Now, this really doesn't indicate which one's 45 and which one's 30. So let's go look at this comparing. Which angle is smaller? Is it this one or this one? This one is actually smaller. So because you got to think, if you're further away, that angle coming up is down more. Okay, the angle. Where the closer you are, the more your head looks up, right? Okay, so this is 45 and this is 30. What is our problem? Our problem is we only know this length. We don't know the full length. And we need the full length for that second triangle to do anything for us. So we have an unknown. I'm going to make that x. All right, for both of our triangles, we are going to make a separate trig equation. Okay, so the 45, we have opposite, which is h, and hypotenuse, opposite, which is h, and the adjacent with, which is x. So that's tangent. So tangent of 45 equals h over x. Our second triangle, we have 30, we have opposite is h. What is the adjacent in this case? What is this whole side? X plus 200. So we have tangent of 30 equals h over x plus 200. All right, there's a lot of variables in here. We want to make sure that this is really going to be okay. Well, let's actually calculate the tangent 45 and the tangent 30. Well, tangent 45 is 1. So 1 equals h over x. What does that mean? That means that x equals h. Okay, here's what I'm going to do when I rewrite this. Well, we know tangent 30 is the square root of 3 over 3. We know that we have h over. Now, instead of x plus 200, let's bring in that h because we know that x equals h. So that way we're only dealing with one variable. Because what are we solving for? We're solving for h. This was our major task. Okay, fractions, don't like them. Let's cross multiply. We get square root of 3 times h plus 200 equals 3h. Too many h's still, we got to combine them, but we have this problem here. We have distributing. So let's distribute. That's the only move we can make at this point. So square root of 3h plus 200 square root of 3 equals 3h. 2h is still, I want to put them together. So I have to move all the h's to one side and everything without an h to the other. So I get square root of 3 h minus 3h equals negative 200. Oh, I guess I could have done it the other way. Yeah, let me just do one movement instead of two. I don't know why I think I'm just so used to having my variable on the left side, but we don't need it, right? So on the left side, we have 200 square root of 3 equals 3h minus square root of 3h. We can now, and I'm going to move it over here, we can now factor out an h, which will allow us to only have one h. And how do you get h by itself? Divide both sides. So h equals 200 square root of 3 all over 3 minus square root of 3. It says to the nearest foot, so we are going to use our calculator. This is approximately 273 and 21 hundredths, which rounds to 273 feet. Okay, one more. Be careful when it comes to drawing things out and putting your measurements in the correct place, okay? How long must the ladder, so we're solving for the ladder, be to reach windowsill 50 feet above the ground? Okay, so we have our window. We have a ladder that's leaning against it. Hopefully our house is constructed really well, and that's a 90 degree. Excuse me. The windowsill is 50 feet above the ground. The ladder is what we're trying to find. And the angle with the ground, so that's the angle of elevation, is 75. Okay, so it looks like we have opposite and hypotenuse. So that's sine. Sine of 75 equals 50 over h. Now, one of the things that's very, very important is do not start rounding in the middle of your problem. Okay, so this, we don't know this by heart, right? We have to use our calculator for this. But if you plug sine of 75 in there right now, you would get a decimal. I don't want to start using decimals, irrational decimals, until the very end. Okay, so I'm going to solve for h first, and then we're going to plug it in all on our calculator. So I would multiply both sides by h, and then divide by sine 75. So I get h equals 50 over sine 75. When you plug this into your calculator, you would get 51 and 76 hundredths feet. Now, because it doesn't tell me how to round, that's how I'm going to keep it. Now we're done. Happy practicing.